Welcome to the Production Dojo, where we're totally not building a giant robot. We promise.
Hi, and welcome to the Production Dojo. My name is Ken, and I'm here with...
Hi, I'm Liam.
Here at the Production Dojo, our purpose is to explore pretty much everything that you need to do to take a great idea and make it actually work, an actual physical item or a product. So we're going to be talking about hardware, software, the design behind these things, creating the media that you might need around it. And we've discovered that it's sort of where all these things come together, where you need a little bit of this skill and a little bit of that skill, and that's where things get really interesting. And those are the sort of things we're going to be talking about. Okay, so with that done, now we're into introducing the first blog post. Let me get to that. Let me pull that up.
So let's see. So it's been a while since we've had a blog post up, and that's somewhat been purposeful. We've actually been doing a fair number of projects. A lot of them have been for clients that we can't really necessarily share specifically who they're for. Some of them have actually been pretty fun, and we'll start to dribble out snippets of the interesting things that we've discovered along the way as we've been playing with materials and working in our core competencies as developers. This particular blog post that we have currently is about something that's been on my mind for a little while, a few months actually. As we've been doing more with our printer bots, we've actually come across a need for stronger prints. And when we talk about the strength of a print, I'm really referring to 3D print being able to be a component within a machine or within some other type of mechanism. When we talk about the strength of a 3D print, in this case we're talking about its ability to not only function as a component within some other mechanism, but its ability to handle stress, to take pressure and not crack or cave. Anyone who's printed any model from Thingiverse with the default infill has come across a situation where, unfortunately, they'll go to turn a head or move a piece of it and it'll just snap off. Well, a lot of that comes down to how solid the model is on the inside. And that's what was the genesis for this particular post about infill.
So yeah, in looking at the graphics and in talking to you about the project that the blog post represents, one of the things I like about what you've got here is this idea of sort of continuous channel or an open channel infill where you could then have a cavity within the 3D object. And this was something that I'm really interested in because I have been working on a piece for a client, and one of the problems I've been having is 3D prototype printing is great, but even with some of the more exotic filament materials, I'm having a real hard time keeping my print costs, my print times down, being able to print it on the printers I have available to me, but still getting sort of the heat characteristics and the strength of a more conventional plastic or, a more conventional epoxy even, which might have been something I would have been using if I wasn't 3D printing. I love the idea that I could 3D print the shape and the shell and then get a sort of composite set of mechanical properties by taking, a regular plastic that might be already well known in manufacturing circles and sort of filling these parts with that material or another type of material. Does that make sense?
Makes total sense.
So is that something that was something that was on your mind when you were thinking this through?
Yes. You got my point exactly. A lot of the strength in having an ability to come back after the print and fill in the model with another material allows for the cost of the print to actually be kept down, and more importantly, the time for a print and a prototype to be kept down as well. As great as 3D printing is, and as much as I love it, it does take quite a while once you actually have a model that you need to try to fill in as much of the inner cavity of the print as possible. That can take a print from 15 minutes up to several days, the more material you try to get through the very, very tiny extruder.
Now, something that folks who have been paying attention and hearing 3D printing or know something about it but maybe don't do a lot of 3D printing themselves might be thinking is, well, all the 3D prints they've seen in process are already mostly hollow. There is a lot of empty space inside. And so why is the infill, and that's what that's called for those of you following along at home, that the infill is the pattern of plastic that sort of takes up the hollow volume inside as opposed to just printing a solid piece. So where does the infill that we're sort of using now fail for this purpose for somebody who's not really maybe doing a lot of printing and looks at a print and goes, hey, there's a lot of empty space in there. Can't I just fill it now?
Well, the purpose of infill as we currently have it is to provide stability for the extruder when it needs to build up the print. So the extruder can't actually place plastic into an empty point in space. It needs to build up atop a previous layer of plastic or the build plate. What the infill that we currently have allows for is a successful print because the extrusion nozzle can build off of the internal lattice, whatever configuration that may be. Where it fails is that, and this is part opinion, but also I think very much the truth, we don't need that much material inside of most prints in order to have a successful product at the end. So let's take a cube, which is the example that I use in the blog post. Because it has a very broad top, very flat, we do need some type of internal lattice in order to build up the walls and then have something for the extrusion head to be able to construct the top of the cube, that very flat surface. But if we were doing something like a sphere, well, the extrusion head can actually construct almost the entire sphere without any infill because it's able to build atop the previous layer of the sphere's outer wall without the need for any type of support material on the inside.
So it sounds like what we're really talking about is that there's sort of a tension or a trade-off between the purposes of infill, that, some infill is used to manipulate the mechanical properties of the final object, the strength and the weight, but that a lot of infill really exists just so that the part is printable, so that there isn't plastic hanging out in the middle of nowhere, and that maybe the software we have now doesn't provide you all the options you want for how you can manipulate those choices. Is that about right?
That's pretty accurate, yes. There is, of course, the mechanical aspect of this, and the people who create the software that we use certainly understand this a lot better than I do, but as I've been doing this for, I think, maybe 2 or 3 years now, we've been dealing with 3D printing. I've just noticed that we just have this opportunity to move the ball a little bit forward on not only how we deal with getting a print and just using the bare minimum amount of material to do that, but also allowing for an opportunity to explore different ways of making structurally sound prints.
Yeah, well, I think once we're freed from having to only be dealing, because that's what this really does, is it frees me as the person doing the print and making those choices from only being limited to materials that my printer can print. If there was a form of plastic that had some mechanical properties I really wanted that's not one of the available filaments from my printer, or would just take forever to print, I love this idea of setting the infill up so that then I can essentially fill or infuse the part with the other mechanical properties I'm looking for.
Right, and what I've really started to feel about this and what I want to explore a little bit more is to start to work with materials that can't be 3D printed, but will be very quick to work into the print, or if they're not quick to work in, provide a stability or a weight or solve a particular need that that particular print has, which exists completely outside of 3D printing entirely. I love 3D printing, but I don't think that it is just about having a pretty piece of shaped and artistically sculpted plastic. There are some very practical uses for the things that come out of this printer. Within the post, I talk about a couple of different methods for doing infill, but the big thing here is, I think, the mental leap to just take a step back and say, we currently have a perspective on infill, and it's a very good solution for the majority of things that people are looking to print nowadays. But what if we just don't need all of that material? What if we can provide stability in another way? And once we actually ask that question and take a step back away from the grid, that's the thing that I feel really opens us up to put any kind of material in. I know that you'd mentioned epoxies and plastics, but one of the methods that we talk about in the post is having a big open channel and just dropping ball bearings into it. So if I don't want my print to topple over, if I just need something that is heavy enough to stand up to someone brushing against it on my desk, I can put in sand, I can put in ball bearings, I can put in whatever material I have handy. There are a couple methods that we do have in the post. The one that I'm the most excited about, though, is having an ability to let things that flow like a liquid have the freedom to move throughout the print. So if I were to put in, say, an expanding foam, or if I actually wanted to have something that had rubber or some other material, I could do that because I now have channels that allow a material that can flow the freedom to flow and fill the model on the inside without being impeded by a very closed-off lattice, which is something akin to what we have right now.
And I think that's really the core thing that it took me a little bit of time when we first spoke about this to really get a handle on the advantages of. The cells, you could think of it as the cell structures we use now for infill. I couldn't guarantee that pouring a liquid or any other thing into one section of the print, that there might physically not be a opening for it to get through the entire other part of the print. And what we're really talking about here with what you've done is essentially mathematically guaranteeing via the pattern that every area of the print would be, or every desired area of the print would be open for the free passage of whatever material you've decided to feed into it from place to place, that no place was a dead end or closed off. And once I really got a handle on that, like the advantages are, what we can do with that is pretty astounding.
I think so, at least.
Well, I mean, that's one of the reasons of doing this podcast, and one of the reasons for the blog post is, now to put it out where the community can get its hands on it. And, there's a lot of very, very smart people in the maker community. And it'll be really interesting to see what people do with the idea, or if people point us at similar ideas, or if somebody can, explain to us why it's very clever, but this is why it might not work. That's the sort of feedback that I think I'm really looking forward to getting from putting stuff like this out. And the production Dojo as a whole is that idea of having that two-way communication with the audience.
Right. And I'm really, really looking forward to doing a few of these prints over the weekend, possibly with a bit of follow-up on the blog, just showing how we've implemented this and if our assumptions are correct. Right now, I don't want to make this sound like I'm 100% positive that this will work, because I haven't actually done a print. As I've looked at it, as I've actually gone ahead and put my modified lattice into a cube and just kind of flown around it in 3D, I really didn't come across an area where I couldn't, at least in my mind, imagine some liquid being able to flow. And I have a really strong feeling that this is going to work, and it's going to be fairly reliable for what we're trying to do.
Well, that's the beauty of the 3D printing stuff is, you can have an idea like this and sort of bang it out over the weekend. And and we'll talk about this in the future, but thankfully we now have some printers that are reliable and we can actually do this sort of thing without coming back to a big mass of plastic that doesn't look like anything we were thinking about. Shout out again to Brooke and the guys at PrinterBot, but we'll talk about that more some other time. Okay, so to the audience, come back when we have some of these prints done, and we'll have a follow-up post, and you'll get a chance to see what we came up with and what the prints look like, and hopefully they can, I don't know, William, if you have a hacksaw, maybe, you print one of these things out and fill it with something and then cut it in half, and we'll take some pictures and see what's going on in there.
Actually, I've got some interesting ideas on how to make that work. But yeah, it doesn't quite involve a hacksaw, but we can certainly show something.
Sounds good. Any last thoughts before we sign off?
Yeah, I think that, this is definitely something that I'm excited about. I think that it's great to actually be able to put something on a production dojo again that we can actually share, and I'm really looking forward to being able to have more dialogue and more interaction with people who are in the maker movement and who aren't in my immediate vicinity. And I think that a lot of what we're trying to do and what we're not necessarily presenting ourselves as experts or dictators, we're just two guys who want to share a few things, and more importantly, we want to share the things that we're doing with people who might be able to correct us or to give us some feedback that puts us along a path to a better solution.
No, I feel exactly the same way. As devs, one of the things I've come to take for granted is that it's very easy for me to share my work with a wider audience and get feedback on it. It's easy to put a piece of code up on a repo and open it to the world and have people look at my code and come back. When you're making physical objects, when you're welding stuff and 3D printing stuff and cutting stuff and building things, video and audio, you have to really go that extra step to make what you're doing available to an audience so that they can feed back to you and interact. And that's what I'm looking forward to most with the Production Dojo, is now very consciously saying, let me videotape what we're doing. Let's take some pictures. Let's publish some code. Let's show the renders. And taking the time to take what we've been doing all along on our own and putting the effort into consciously sharing it out with our audience. I think that's going to be a lot of fun for everybody.
Agreed.